The screwdriver trembled slightly in Oberingenieur Kloss, Hermann's hand, as he finally broke the seal on the metal case of the captured American radio set. The air in the underground laboratory was cool and still, smelling of damp concrete, ozone, and hot vacuum tubes. Around the heavy wooden workbench, 5 of Germany's finest radio engineers leaned in, their collective breath held. For 3 years, they had been assured by Berlin that American technology was inferior, mass-produced junk created by a nation of shopkeepers and assembly line workers. The official reports from the Radio Intelligence Service were adamant. The Americans relied on outdated equipment, primitive designs, and poorly trained operators. Yet, a dissonant truth had been gnawing at them. Allied forces maintained constant, clear communication across impossible distances. Their fleets never lost contact. Their ground units, from platoon to army, coordinated with a precision that whispered of a sophistication far beyond the crude, static-ridden sets German propaganda described. This captured equipment, this SCR 508 from a destroyed American M4 Sherman tank, promised answers. The case opened with a final, metallic sigh. Inside, nestled in a rigid, rubber, shocked mounting, was the radio. It was not what any of them had expected. There was no bird's nest of hand-soldered wires, no complex array of adjustment screws needing a technician's delicate touch. Instead, they were met with a landscape of clean, modular units, each painted a uniform olive drab and connected by standardized quick disconnect plugs. Every component, every resistor, every capacitor was identical to the schematics found in the pristine technical manual tucked into a compartment on the lid. This was not an instrument crafted by an artisan. It was a product, engineered, predictable, and built to be duplicated by the tens of thousands. The first true shock came when Lieutenant Heinz Schreiber, the team's specialist in frequency control, gently extracted the crystal unit. He had expected, perhaps, a simple, inexpensive quartz slab, or even repurposed civilian components. What he held in his palm was a masterpiece of precision. It was a hermetically sealed metal can, inside which a flawless wafer of quartz was ground to a tolerance measured in parts per million. He examined it under a magnifying lamp, his eyes wide with disbelief. This single crystal, with its perfect electrodes and laser, etched frequency specification, would have cost more in materials and skilled labor than an entire German Fuge 5 tank radio. And there were 10 of them. 10, installed in a standard tank radio as casually as light bulbs in a fixture. In the Reich, crystal-controlled oscillators were reserved for high command stations and aircraft, their scarcity and cost justifying their limited use. Here, in a single medium tank, was a fortune in frequency stability. Schreiber's hands shook as he replaced it. He counted the channels again. 10. A tank commander could simply turn a knob and switch between 10 pre-set, crystal-locked frequencies. In a German tank, changing frequency was a 5-minute ritual of manual coil swapping and delicate tuning, a task for a trained radio operator, not a tank commander. Oberingenieur Hermann began drafting his preliminary report to the Wehrmacht High Command. The words formed with the heavy weight of heresy. He described the heavy, gauge steel case, the superior rubber gaskets that promised protection against dust and water, far exceeding German standards. But the external ruggedness was merely the prelude. The internal architecture spoke of a different world. The radio used frequency modulation. FM. They had all seen the theoretical papers. FM was superior to their own amplitude modulation, immune to static, clearer in transmission, more resistant to interference. But it was complex, temperamental, and required exquisitely stable frequency control. The German High Command had deemed it too expensive, too complicated for field use. Yet here it was, in a mass-produced unit operated by common American soldiers. And it tuned itself. Hermann traced the circuit with his finger, his mind grappling with the elegance of the automatic frequency control loop. German radios drifted with temperature changes, with the aging of components, with the vibrations of travel requiring constant, skilled adjustment from the operator. This American set, through a clever feedback circuit, locked onto its frequency and held it, day or night, in the desert heat or the mountain cold. It was designed for a simple, devastating reality. The man using it did not need to understand how it worked. Over the next 72 hours, the laboratory became a chamber of mounting dread. They connected the SCR 508 to their power supplies and antennae. The transmitter produced a clean, 25-watt FM signal. The receiver, when subjected to simulated engine noise, stripped away the interference with ruthless efficiency, delivering audio clarity that was nothing short of magical. They conducted range tests, establishing crisp contact with a monitoring station 20 kilometers away, a distance at which German AM sets would be a cacophony of static. Schreiber focused his despair on the crystals. He calculated that to produce just one of those 10 precision oscillators to the American specifications would require 40 hours of a skilled German technician's time in a calibrated laboratory. The Americans had installed 10 in one radio. Intelligence suggested they had built thousands of Sherman tanks. The math was apocalyptic. He posed the desperate question in his report: where were the Americans finding the hundreds of thousands of trained technicians needed for this? The answer, when it filtered back from intelligence sources, was a second, deeper shock. They weren't using highly trained technicians. The Americans had industrialized the very art of precision. In cities with names like Chicago and Fort Wayne, factories staffed by thousands of semi-skilled workers, mostly women, operated specialized grinding machines. Precision was ensured by optical comparators and automated frequency counters, not by the sensitive hands of a master craftsman. Quality was a statistical process, managed through random sampling. They had not just built a better radio, they had built a system to build radios. A system that scaled in a way the German workshop model simply could not. Hermann's final report to Berlin was over 200 pages long. It was a meticulous, damning indictment of their entire technological paradigm. He concluded that the American equipment was 5 to 10 years ahead in key areas like FM, crystal control, and automatic circuits. More critically, it was designed from the ground up for mass production. He estimated that to match this capability, Germany would need to build 30 new specialized factories, train 50,000 workers, and invest resources equivalent to the entire annual Luftwaffe budget. And even then, they lacked the raw materials, particularly the high-quality quartz. The report was classified Geheim Kommandosuchi, most secret, and sent to a handful of senior officers in the High Command and the Reich Ministry of Armaments. The response was a resounding, terrified silence. No new factories were authorized. No crash programs were initiated. The truth was too devastating to acknowledge. But the work of Technical Testing Station 12 was only beginning. The tide of war brought more captured equipment, each piece a fresh lesson in industrial terror. An SCR 300 walkie-talkie, a backpack FM radio that weighed a mere 18 pounds yet provided clear communications for 5 kilometers, appeared. Its German equivalent was a 40-pound monstrosity that required an external 20-pound battery. An SCR 299, a long-range communications truck, was captured in Sicily. It packed the power and capability of a German, fixed, station communications center into a vehicle that could be driven anywhere and set up in an hour. A pattern emerged, clear and chilling. American equipment was designed for operation by minimally trained users, for mass production by semi-skilled workers, and for maintenance by following simple, step-by-step procedures. German equipment required skilled operators, hand assembly by trained technicians, and field repairs by electronics experts. One philosophy could scale to millions of units and global deployment. The other could not. By the summer of 1943, the intelligence painted a comprehensive picture. The Americans had a layered, interoperable radio network. A platoon with an SCR 536, handy, talkie, could talk to a company with an SCR 300, which could talk to a battalion with an SCR 508, which could link to a regiment with an SCR 299. It was a web of connectivity, all on compatible FM frequencies. German forces struggled with a patchwork of incompatible AM systems, each with its own procedures and parts. Hermann, now transferred to a larger facility in Italy, shifted his focus from the radios themselves to the industrial machine that produced them. His reports became strategic warnings. He documented the explosive growth of companies like Galvan Manufacturing, which would become Motorola and Hallecrafters, outfits that had transformed from small, time radio makers into military production behemoths virtually overnight. Western Electric, the manufacturing arm of the Bell system, was employing tens of thousands. Detroit's automotive engineers had applied assembly, line logic to radio production. The German radio industry, in contrast, remained a collection of small, specialized firms, producing hundreds of units a month with the careful hands of craftsmen. His December 1943 report, The American Radio Industry, an assessment of industrial capacity and strategic implications, was a masterpiece of terrifying clarity. The United States was producing annually what would take Germany 2 decades to manufacture. The gap was not merely technological, it was philosophical. The Americans had enough radios to equip 1,000 divisions, though they fielded only 90. A damaged radio was not repaired in the field. It was swapped out. A new model was not a prototype. It was introduced across an entire army. The crystal supply became the ultimate symbol of the chasm. Germany needed 5 million precision crystals and could make perhaps 200,000 a year. Intelligence indicated America was producing 30 million. They had solved the quartz shortage through massive mining operations in Brazil and Arkansas, and were even experimenting with synthetic crystal growth. The examination of American test equipment was the final, humiliating blow. They captured a standard American signal generator, a device that could create perfectly calibrated radio signals for factory testing. It was a sophisticated instrument, yet it was produced in such quantity that every assembly line station had one. It cost the Americans about $300. The equivalent German capability required a room full of custom-built, temperamental equipment that cost thousands of Reichsmarks and required a PhD to operate. The Normandy invasion in June 1944 was the living proof of their worst fears. Every Allied company, battalion, and regiment was a node in a vast, resilient communications network. German commanders, trying to coordinate a defense, found their communications dissolving under the chaos of battle, their complex, operator-dependent radios failing them. The reports flowing back to Berlin were desperate. Hermann, now attached to the Wehrmacht operations staff, wrote in August 1944 that Germany had already lost the electronic war. American jamming, direction finding, and signal intelligence capabilities could locate and target any German transmission within minutes. The end was a slow, grinding silence. As Germany's industrial base was bombed into rubble, radio production ceased. Telefunken's Berlin plant was destroyed. Lorenz's factory in Stuttgart was flattened. When a German radio failed, it was often the end. There were no replacements. Technicians became scavengers, cannibalizing wrecks to keep a precious few sets alive. The Americans, meanwhile, continued to refine their designs, their depots overflowing with equipment that would never see combat. On May 8, 1945, it was over. In the aftermath, American investigators were stunned to discover the thorough, accurate, and profoundly pessimistic German technical intelligence reports. They had understood their own doom with chilling clarity. One of Hermann's final reports, written in April 1945, as the Soviets closed in on Berlin, served as his epitaph for the Reich. He concluded that Germany's defeat was inevitable from the moment they opened that first SCR 508 in Tunisia. The frequency crystals, the automatic circuits, the modular design. They revealed an industrial philosophy Germany could never match. The Americans had industrialized warfare itself. Germany had excellent soldiers and competent generals, but they had tried to fight an industrial war with craftsmen's methods. The post-war fate of the engineers was a final irony. Klaus Hermann, like many of his colleagues, was recruited by American intelligence in 1946. He spent years documenting German technology for his new employers, and later worked as a consultant for American electronics firms. The brain drain, formalized in programs like Operation Paperclip, transferred the very men who had diagnosed Germany's weakness to the nation that had embodied that strength. They brought their knowledge with them, but more importantly, they absorbed the American methods of mass production and industrial organization. In 1952, Hermann published a paper in the Proceedings of the IRE, a dry, academic treatise titled Comparative Analysis of German and American Military Radio Design Philosophy, 1939-1945. In it, he formalized the lesson he had learned in that Tunisian bunker. American design prioritized ease of manufacture, simplicity of operation, and reliability. German design sought technical excellence and theoretical perfection. One philosophy scaled to global war, the other did not. The paper became a foundational text, influencing a generation of engineers who would build the systems for the Cold War and the space race. The principles visible in the SCR 508, design for manufacture, standardized components, build-in reliability, scale to demand, became the bedrock of modern high-technology industry. Decades later, at an engineering conference in Munich in 1986, an elderly Klaus Hermann displayed photographs of that first examination in 1943. He told the audience that the moment he saw those 10 precision crystals in a standard tank radio, he knew the war was lost. That small piece of quartz was the intersection of physics, engineering, and industrial organization. To produce one was a feat of skill. To produce millions was a feat of society. The infrastructure America built to grind those crystals did not vanish in 1945. It evolved, producing the transistors, the integrated circuits, and the microprocessors that would define the modern world. In 1995, the Smithsonian Institution exhibited an SCR 508, the very one Hermann's team had examined. Beside it were translated excerpts from his reports. The display was not about glorifying American technology, but about demonstrating a fundamental shift in warfare. Victory was no longer solely the province of the brilliant general or the brave soldier. It now belonged to the nation with the greater industrial capacity to produce high technology equipment in overwhelming quantities. The exhibit's final display was a single, hermetically sealed radio crystal. The label explained that this one component, one of 10 in a single tank radio, represented 40 hours of German, skilled labor to duplicate. The Americans had made over 100 million of them during the war, an output that would have required every German radio technician to work for 500 years. Klaus Hermann died in 1997. His obituary noted his lifelong insistence that Germany's defeat was determined not on the battlefields, but in the factories. His personal papers, donated to the Deutsches Museum, contained a poignant letter he wrote to his wife in the final days of the war. In it, he reflected that America possessed not just better equipment, but a fundamentally different approach to warfare. They had industrialized everything, Germany had fought an industrial war with craftsman's methods. "Theory does not win wars," he wrote. "Production capacity wins wars." The story that began with a trembling screwdriver in a Tunisian bunker is the story of that realization. It is the story of the moment when warfare was irrevocably transformed, when the precision ground quartz crystal became a symbol more powerful than any general's baton. It was a lesson written in frequency and amplitude, a lesson about scale, organization, and the relentless, world-changing power of industrial might. The German engineers who examined the American radios were among the first to see the future, and they understood, with terrible clarity, that it did not belong to them.